this is in continuation with HPAS 2019 main paper 2, and this is question number 4. In question number 4a, it has been asked that solve the following equations by Gauss-Seidel method correct to 2 decimals. So these are the 3 equations. So basically Gauss-Seidel method means the iteration up till the convergence is achieved. So the step by step, first of all we are going to choose the initial values of x1, x2 and x3. So let us say that x1 is equal to 0, x2 is 0 and x3 is also equal to 0. So based on this, what we do, we calculate the new variables using the following equation. So we write the new variables as x1 new, which is equal to 6 minus 6x2 minus 2x3, and similarly new variable of x2, which is represented by x2 new, is given as 12 minus 5x1 new plus x2, and similarly the last x3 new is equal to minus 4 minus 3x1 new plus 2x2 new divided by 8. So these are the 3 equations which we get by getting the new variables. In the step number 3, update the variables x1 as x1 new, x2 as x2 new and x3 as x3 new, and this we are going to repeat steps 2 number 3 until the convergence is achieved. So convergence is basically what we do. In convergence we determine by comparing the new values with the previous values. So what we do, we compare the new values with the previous values and see where the difference lies, or we can say if the difference is below the tolerance level or not. So this entire 4 steps are shown in the form of table 2, and it is rounded up to the second decimal. So in the iteration 1, we get value of x1 as 6.00, x2 will be 2.17 and x3 will be this, and this goes on repeating. So we can say that after iteration number 4, the value starts to repeat itself, that x1 comes 5.29, in iteration number 4, 5 as well 6. Similarly, x2 comes as 3.01, 3.01, 3.01, and the last value x3 also repeat itself with minus 1.x3. So it means after 6th iteration the value has converged. So we can say that by the solution will be approximately given as x1 is equal to 5.28 and x2 will be equal to approximately 3.01 and x3 is approximately equal to minus 1.36. This was the question number 4a. Now the question number 4b. From the following table, obtain f of 2.07 using the best formula. So the table is given. First of all, we are given the value of x, which is 2, 2.05, 2.1, 2.15, 2.02 and 2.25. Now we have f of x as 0.69315, and this is a value of f of x. Now to obtain the value of f of 2.07, we are going to use the best formula by using the interpolation techniques. So in this case we can see that the data points are not evenly spaced. So as the data points are not evenly spaced, what we are going to do, we are going to use a Lagrange's interpolation method. What happens in Lagrange's interpolation method, it allows us to construct a polynomial that passes through a given data points. Okay, so this polynomial will be constructed such that it passes through the given data points and can be used to estimate the values of other points. So the basic formula for Lagrange interpolation is given by f of x is equal to summation 1 to I goes from 0 to n f of xi and L of ix, where the summation represents the summation. F of xi is the value of f of x at data point xi, and Lix is the Lagrange basis polynomial. So to find value f of 2.07, we need to calculate the Lagrange basis polynomial and evaluate the polynomial at the value of x is equal to 2.07. So this Lagrange basis polynomial is given by the equation L naught x is equal to x minus x1 divided by x naught minus x1. L1 x is given by x minus x naught divided by x minus x naught. Substituting the given formulas, we get L naught 2.07. We already know these values, which is approximately equal to 7, and we find out L1 2.07. By substituting the respective values, we get L1 207 is equal to 0.34. Now we can calculate the value of function 2.07. So we can say that function 2.07 is approximately equal to function of 2.0 multiplied by N naught 2.07 plus function 2.05 multiplied by L1 2.07. So we already found out the value of L naught and L1 respectively at 2.07. So you simply substitute the values. F of 2 naught is itself given in the question, that is 0.69. We substitute that value, and f of 207 we already calculated is equal to 0.7, and similarly we know the value of f of 2.07 as well as f of L1 2.07. So you solve this, we are going to get value as approximately 0.7285426. So we can say that using the Lagrange interpolation, we estimate that value of function f 2.07 is approximately equal to 0.7285426. Thank you.